Hello everyone. So today we're going to go over the chapter 9 review. So we're going to look at a pattern and answer questions using what we know about linear relations. As you can see here, we have three figures, number 1, 2, and 3, and they appear in sequential order. So the first thing we're going to consider is the figure number and the number of squares in each one. And for that, we'll use a table of values. The independent variable will be the figure number. So we'll put that in the top row, and we'll use the variable f for the figure number. So you can see here we have figures 1, 2, and 3, and we will extrapolate to 4, 5, 6. So 1, 2, 3, 4, 5, and 6. Now, if the number of squares is the dependent variable, as you can see, the number of squares depend on the figure number. And we will call that variable s. So you can see the first figure has 5 squares. 1, 2, 3, 4, and 5. The second one, now, of course, you can already see that on the inside we have the original figure number 1, and then we have 4 additional squares on the outside. So 6, 7, 8, and 9. So for a total of 9 squares. And likewise, of course, for figure number 3, we already have the 9 squares in the middle, um, and then we have 4 more. So that will be 10, 11, 12, and 13. So figure number 3 will have 13 squares. And you can see already that we have a common difference of 1 for the figure number, and a common difference of 4 in the number of squares. Okay, so um, 13 plus 4 then is 17. Then we have 21, and then we have 25 squares for figure number 6. We're going to describe the pattern in the table of values, so just using words then. As the figure number, or as f, increases by 1, starting at 1, the number of square s increases by 4. Oh, sorry, I missed the word there. Okay, let's fix that. So as f increases by 1, starting at 1, s increases by 4, starting at 5. Figure number 1 has 5 squares. Okay, so that's one way to describe the table of values in words. So from there, what we're going to do is we are actually going to jump ahead to page 3 to draw a graph of the table of values. The reason why we have to jump to page 3 is because that's where we have our grid. Okay, so let's look at what we have. We have a line this way. Oops, gonna make it vertical axis and then a horizontal axis, of course. Gonna draw some arrows in. There we go. Now the x-axis will be the figure number, so that will be f, and the y-axis will be filled with the squared number of squares, which is s. So we're going to go ahead and write out the axes. We have first 6 figures of 1, 2, 3, 4, 5, and 6. And then on the y-axis, we will have the, let's go with 5. 5, 10, 15, 20, 25, 30, and that's enough. Okay, so if you read the table of values on page 1, we'll have the point 1, 5, so that's easy to plot. And of course, the plot of 625 is also pretty easy. For the points in between, notice that here, every square goes up by 5. So if we want to go up by less than 5, we have to go a fraction of the way up. So 2, and then 4/5 of the way up. So this will be 2, 9. And then we have 3, 13. So maybe there. 4, 17. So this is 4, 17. And finally 5, 21. So that will be 1/5 of the way up from 20. This is 2/5 of the way up from 15. And if you did this reasonably well, you will get a straight line. Okay, and you can show that by drawing a straight line through the points, like so. Okay, so now a couple of things to notice, just like before. It does intersect the y-axis. The y value here will be 1. And what is important about that value is that if you have figure 0, it would just be a single square. So that's important to note. Maybe in a different color. Okay, so this would be the point 0, 1 if we have figure number 0. Okay, let's go back. So the question is this a linear relation? So based on your graph, of course, yes it is. So yes, 2 ways you know. Number 1, the graph forms a straight line. And number 2, of course, is the common difference are constant. The common difference is for the f variable is 1, and for the s variable was 4. And that's how we know we have a linear relation. Okay, so of course, if you have a linear relation, it's very easy to extrapolate what happens in other figures. So consider if we have figure number 10. So what you can do is you can do a continuation of the table of values. So 7, 8, 9, and 10. And as you know, as the figure number increases by 1, the number of squares increase by 4. So we will go from 25 squares in figure number 6 to 29 squares in figure number 7, 33 squares in figure number 8, 37 square in figure number 9, and 41 squares in figure number 10. Okay. So now another way of doing this question, instead of making a longer table of values, is you can also use a formula. Okay, let's make this formula together. We know that the number of square s is equal to 4 times the figure number, because of course the number of square increases 4 times as fast. A number of squares increases 4 times as fast. Now, but of course figure number 1 doesn't have 4 squares, it has 5 squares. So we need to consider that difference there, and we're going to add 1, this constant here. So you can think about this constant in 2 ways. Number 1, add, sometimes you might subtract instead, depending on the question. add or subtract constant to fit table of values. And the other thing that you might want to do is, in this case, you can consider figure 0. In figure 0, you have 1 square. Okay, so once you have a formula established, then you can use it to predict how many squares you have for larger figure numbers. So in this case, we'll let the 50th figure, so we will let f equal to 50. Of course, 4 times 50 is 200. And then you have 200 plus 1, which is 201. Squares. Always remember your units. Okay, so now what is important about having a formula is we can also use it to determine the figure number based on the number of squares. So in this case, we have 61 squares, and we're trying to figure out the figure number. So we're going to have 4f plus 1. We're trying to solve for f. So in order to do that, we're going to subtract 1 from both sides. So 61 minus 1 is 60, and the plus 1 minus 1 will eliminate each other, so we have just 60 equals to 4f. And then if we divide both sides by 4, we'll have f equals to 15. So this would be figure number 15. Now, in this case, it doesn't make sense for us to connect or have points in between the points because we're not going to have figure number 1.5. So let's look at what that means for something like an example like this one we have here. 96 squares, is that possible? So 96 equals to 4f plus 1. We'll do something similar to the last question. We'll subtract 1 from both sides. So we have 95 is equal to 4f. So for those of you who are very good at dividing, you will notice that it doesn't divide evenly. So f is going to be equal to 23.75. So not a possible figure. Okay. So the next piece is to consider the same set of figures, but instead of looking at the number of squares and the figure number, we're going to look at the perimeter of each one. And to do that, we're going to scroll back up to the first page and see what that looks like. So let's go. Oops, sorry. All right. So the first figure, and we're going to count each edge as unit 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Figure number 1 has a perimeter of 12 units. Figure number 2, you can do the same thing. 1, 2, 3, 4, 5. And you'll notice that there's 5 units worth of perimeter on each wing, if you will, of this figure. So that will be 20 in total. And here, last one, 1, 2, 3, 4, 5, 6, 7. And you have 4 of those, so 7, another 7 on the right, 7 pointing down, and 7 pointing to the left. So of course, 4 times 7 is 28. So we can use this information to fill out our table of values right here. So again, we have the figure number, f, and the perimeter is our dependent variable, so this would be perimeter, which is p. Again, for the first 6 figures, so 1, 2, 3, 4, 5, and 6. So I think we started at 8. Did we? No. hold on. We start at 12. 12, 20, 28, and you will notice at this point that the common difference is 8. So of course the last three here will be 36, 44, and 52. All right, so once we have that done, we can also write a formula relating to the perimeter to the figure number, just like what we did in the last part with the number of squares and the figure number. So consider we have P equals to the common difference for the perimeter is 8, so we have the multiplier there of 8, F. Same thing as before, if we step backwards to figure 0, we'll, of course, instead of adding 8, we'll subtract 8 from 12. So 12 minus 8 will give us 4. And it makes sense because figure 0 would just be a single square, and a single square has a perimeter of 4 units. So this will be 8F plus 4. Okay, so coming up with these formulas is sometimes a little bit challenging, but if you think about it in terms of what happens if x is equal to 0, and then taking a step back like we have here, then generally it's actually pretty okay. So that's all I have for today, and thank you for listening.